Hi, organic chemistry has a high weightage in paper 4. Chemistry paper 4 is on February 6, so we need to revise very smartly. For the next 3 to 4 days, we will focus only on high yield topics and revise them using topical past paper questions. Okay, let's start with this question. Propane, propene, propanol and propanoic acid are members of different homologous series. Molecules of these substances contain 3 carbon atoms. Explain why members of a homologous series have similar chemical properties. Now, in organic chemistry, reactions depend on functional group. Methanol, ethanol, propanol, butanol, they all have similar chemical properties because they have the same functional group. So you can write as they have same functional group. Next, name the homologous series to which propanoic acid belongs. Oic acid, the name itself gives hint, it's a carboxylic acid. Great. State the general formula of the homologous series to which propanoic acid belongs. Whenever they talk about general formula, you think about CN like that, CN, H2N, what is it? Now, homologous series of propanoic acid belongs to, so CN, H2N plus 1, which is an alkyl, and carboxylic acid functional group is attached to an alkyl, CnH2n plus 1, COOH. Next, propan 1-ol has an unbranched isomer. Name this isomer. Now, what do you mean by unbranched isomer? Unbranched isomer means you have all your carbons in the main chain. So, only the functional group is shifting its position. That's unbranched isomer. Now, what is the unbranched isomer for prop 1-ol? It will be prop 2-ol. Why? Because we are not changing the main sequence. What we are changing is the functional group. So you remove the functional group from here and you keep it on the second carbon. So the name would be propan 2-ol. Draw the displayed formula of this isomer. So this is the displayed formula. C. Keep the hydrogens. I'm not writing hydrogens, but please write the hydrogens in the exam. Let me also write it just in case. Yes. This question is about organic compounds. Butane reacts with chlorine in a photochemical reaction. State the meaning of the term photochemical. Now, photo means light. Okay, remember that. Photo means light. Now, some reactions require extra energy through heat or light for the reaction to happen. Here, this is an alkane reacting with an halogen. Alkanes will go through substitution whenever they react with halogens. Okay. Now, what is photochemical reaction? A reaction that uses UV light or that needs UV light is called photochemical reaction. Okay. A reaction that needs UV light or uses UV light is called photochemical reaction. An organic compound with the formula C4H9Cl is formed when one molecule of butane reacts with one molecule of chlorine. Draw the displayed formula of two possible structure isomers with the formula C4H9Cl formed in this reaction. Now, displayed formula means you have to show all the bonds, all the atoms. And isomer is same molecular formula, different structural formula. First, let's write 4 carbons, and you can give the chlorine to the first carbon. This is one isomer. And next, you can keep that chlorine to any other carbon, like second carbon. So this is the another structural isomer for this. Okay, moving further. The structure of a compound A is shown in figure 7.1. Reduce the molecular formula of compound A. Whenever they talk about molecular formula, you have to just count the total number of carbons and total number of hydrogens, total number of oxygen. Basically, total number of molecules present in it. Okay. So, carbons. How many carbons are there? 1, 2, 3, 4. How many hydrogens are present here? 1, 2, 3, 4, 5, 6. And how many oxygens are there? 3. Okay. There are 3 functional groups in compound A. Name the homologous series of compounds that contain the following functional group. Any compound that contains C double bond C is called alkene with the E, alkene. And OH is for alcohol. And then COOH, we discussed this. This is a carboxylic acid. Okay. Question number 3. Alkynes and alkenes are homologous series of unsaturated hydrocarbons. All alkynes contain carbon-carbon triple bond. Complete the table 6.1 showing information about the first 3 alkynes. Now, there are 3 carbons here. So it's prop, the starting letter is prop, and there is a triple bond. So it will end with Y and E. Whenever there is a carbon-carbon triple bond, the suffix will be Y and E. So the name is propyne. Here you have to write the formula. So just count the number of carbons. 1, 2, 3, 4. And hydrogens are 6. B part. Compounds in the same homologous series have the same general formula. Give other characteristics, 2 other characteristics of members of homologous series. As we discussed, homologous series, so they have same functional group. Same functional group, and they have similar chemical properties. Deduce the general formula of alkynes. Use the information from table 6.1 to help you. Now, we know alkynes have triple bond. So if there is a triple bond, so you can write, for example, carbon-carbon triple bond, and you have one hydrogen attached and one hydrogen attached, right? So now C2 and H2. So which is CN H2N minus 2. For all alkynes, the formula will be CnH2n minus 2. Now, alkynes are unsaturated. Describe a test for unsaturation. Whenever they ask you for unsaturation test, be double bond or triple bond, unsaturated test, you add bromine water. You add bromine in it. Okay? Why? When you have a unsaturated compound like ethene and when you add bromine to it, what happens is that the bromine will go and bind to the carbons. The double bond will be broken and given it to 2 ends, and the bromine will go and attach there. So therefore, the bromine is brown in color or orange brown in color. So you can just say it turns from orange or brown to colorless. Now just add bromine water. Next, ethene and butene are alkenes. Draw the displayed formula of but2-ene. But means 4 carbons. So first draw 4 carbons and 2-ene. So there is a double bond at second carbon. So, and now make sure you have 4 bonds with all carbons. 1, 2, 3, 4. Yes, 1, 2, 3, 4. 1, 2, 3, 4. Always make sure every single carbon will have 4 bonds. Okay, in your structure. They should have 4 bonds in your structure. Next, draw the dot and cross diagram to show the molecule of ethene, CH2, double bond CH2, show outer shell electrons only. Now, C double bond. Whenever there is a single bond, that means you are sharing 1 electron each. When there is a double bond, you are sharing 2 electrons each. So, you draw 2 carbon atoms and 4 hydrogens. And now, cross dot. So 1 single bond, so 1 electron sharing each. And then this is hydrogen, this is hydrogen, this is hydrogen, this is hydrogen, this is carbon, and this is carbon. Now all of them will have, these both will have 4 electrons sharing between each other because they have 2 bonds. This is the answer. Question number 4. The names of 4 esters are listed. Methyl propanoate, ethyl propanoate, propyl propanoate, butyl propanoate. Esters are a family of organic compounds with similar chemical properties. They can be represented by the formula CnH2nO2. State the name given to a family of organic compounds with a similar chemical properties. They are called homologous series. Homologous series. Next. Explain why members of a family of organic compounds have similar chemical properties. This we already did. This is because they have same functional group. Now, state the name given to a formula such as CnH2nO2. This is called general formula. General formula. Determine the value of N in butyl propanoate. Now, butyl have 4 carbons in it and propanoic acid will have 3 carbons in it. So, it will be 7. Ethanoic acid is manufactured by reaction of methanol with carbon monoxide. Ethanoic acid is a member of a homologous series of carboxylic acids. State the general formula of this homologous series. Now, ethanoic acid general formula, carboxylic acid general formula will be CnH2n plus 1 COOH. This also we have done. Next. Draw the structure of carboxylic acids containing 3 carbon atoms. Show all of the atoms and all of the bonds. 3 carbon atoms. So it will be 1, 2 and 3. C double bond O, OH, and the rest of them will have hydrogens. That's it. Next. Ethene is an alkene which reacts with bromine as shown in the equation. Write the general formula of alkene. Now alkenes will have CnH2n as general formula. H2n. That's it.